the histograms. A histogram is a bar graph which shows a frequency distribution. Real upper limit RUL and real lower limit RLL refer to the true boundaries of a class interval. They are found midway between the apparent limits of neighboring class intervals. Midpoint is equals to LL plus R all over 2. These two will cover them at the end of this chapter, but I just wanted to highlight them at the beginning. When several class intervals at extreme of a distribution are empty, they may be combined into one class. This is a point to note. So these three will be covered at the end of the chapter, but I just wanted to start with them so that your brain will be expecting them. So let's move on. The following are examples of different types of card found in a store. So these are the price of cards, of different types of cards. So we are asked to represent this data in a histogram. So your first step is to make a frequency distribution table for this data. So as you can see, the values of the price range from 0.52 to 3.85, which is roughly from 0.5 to 4. So as you can see, this is the 0.52, the smallest, to 3.85, which is the highest. So now we can then divide the range into 7 equal intervals. So we are starting from 0.5 to 1, 0.5 to 99, 1 to 1.49, up to 3.9. So this is how I decided to. You can divide them any way you want, but for me, I saw that doing them in 0.5 is quite good and neat for me, because if you use like 20, you only have 2 intervals, but these 7 intervals, they're quite a reasonable number. So let's move on. So when you're using, you can see that the way you can do it, you now have your class interval and frequency. So it means you are going to your data like this, then you are selecting each item price and putting them in the corresponding class interval. So the correct way to do them is like when you select, let's say the first one is 0.5, 0.5, forgive me for that too. Let's see, 0.99. Like that. It's like when you select this one, you cancel it, then you say 1 is a tally, then 0.99, you can say 2, so that you won't end up repeating the values. This is just for illustration, but once you have drawn up to 3, up to 4, like up to the last one, it means you'll be just going in order. So which is 1.5, you cancel it, then you put it in the corresponding category, so that you won't end up repeating or missing numbers. So this is how you do it. So when you do it correctly, you should come up with this frequency, and total should be 20. So now you can now draw a histogram. So remember, the histogram doesn't show spaces. So if you draw it correctly, you are supposed to come up with something like this. So it's a frequency. So it's similar to the bar graphs, but the difference is that there is no space between the bars. But here there is a gap because there was no data which was available for prices between $2.50 and $3. So let's move on. Example 2. Using the data below, make a frequency table and histogram of the hours it took students to complete homework. So these are the different times of hours it took students to complete homework. So there's 3, 5, 8, 11. So these are the different times. So you're asked to draw a histogram. So what you do first, you create a tally. So let me demonstrate. So these are the figures or the hours which, so I've categorized so if you see, the data is ranging from 2 is the smallest, up to 23 if I'm not mistaken. So you can use 1 to 5, 5. So 1 to 5, 6 to, like that. So in 5, 5, 5. So like I've demonstrated, it's 1 to 5 hours, 6 to. So I'm categorizing them in these class intervals. So let me demonstrate how to do them. So 3, this 3 is in here. Then 5 is in here. 8 is in this. 11 is in here. 13 is in here. 2 is in here. 19 is in here. 23 is in here. 22 is in here. 25 is in here. 3 is in here. 10 is in here. 21 is in here. 14 is in here. 9 is in here. 12 is in here. 17 is in here. 22 is in here. So it becomes 5 like this. 23 is in here. And 14 is in here. So it's 5. So say 4, 3, 5, 2, 6. So this is how you use the tally so that you won't miss any number. Because once you select it, you cancel it, then you record it. So this is how you use your tally to determine the frequency. So let's move on to the next stage. So the next stage is drawing the graph. So you have your 1 to 5, 6 to 10. Then you put your number of students on the frequency here and the hours taken to complete homework. So this is how you draw your histogram. So notice there is no space between the graphs, and the height represents the frequency. So let's move on. Practice questions for histograms. The table below shows the amplifier gain in dB, decibels. Testing data with high and low values shown in bold. Construct a frequency table and histogram using the given data. So this is the amplifier gain. So the amplifier, they say the high and the low values are shown in bold. So this is the low and the high. So it gives you a range. So your data is ranging from 7.8 to 11. So you can select a. So it's roughly, you can say it's roughly from 7 to 12. Your range. So you can select the appropriate ranges for this. You can even. So the difference between 12 and 7 is about 5. So you can use 0.5, 0.25, depending on how you want to do it. So this is the data, how you do it. So can you try to solve this one and draw your histogram? So pause in 5 seconds. 5, 4, 3, 2, 1, pause. Okay, let's go to the solution. The practice question solution, calculate the range of the data. So the range of the data is from 11.7 minus 7, and we get 3.9. So since the range is approximately 4, we can divide the range into equal class sizes of 0.5. Therefore, number of class you can divide by 0.5 and you get 8 classes. So once you do that, let me repeat it. You first find your range. It's the difference between the highest and the lowest. So the highest is 11.7 minus 7.8, then you get 3.9. So since the range is approximately equal to 4.0, we can divide the range into equal class sizes of 0.5. So this 0.5 is you who determine. You can divide it into classes of 0.1, but it means there will be too many classes. If you use 1.0, it means you only having about 4 classes. So I chose 0.5 because 8 classes, they're quite reasonable to deal with, because remember your data is quite a huge data set, as you can see. So let's move on. So now because you are using 0.5, so as you can see, for this range I'm starting from 0.75 to 8.25. So I'm using difference of 0.5 for each class. So I'm starting from 7.75. We can start from anywhere you want, but it's reasonable to do it in this way. So now you have got your tally, and once I did it separately, then you get your frequency like this. So you can check whether you did the same so that we can reach to a certain conclusion. So let's move on to step 4. So step 4 is drawing your data on the graph histogram like this. So this is the gain in decibels, dB, and frequency here. So you just draw it like this. So you can see it's coming out nicely. So you should get a similar shape like this, provided you use the same. I would recommend using 0.5 because it's quite neat and graph will come out well. So this is how you do it for this practice question. It was a bit more long and difficult to do, but I'm sure once you do such a question, any type of histogram that comes along will be able to cover it. So common histogram patterns. So you can see this is bell-shaped. Let me take the pen here. Bell-shaped. You can see if you would like to select something like this, it's bell-shaped. Then there's double peaked, so it means it's like double peaked. Then there's plateau. It's almost like almost peaked, but it's not. Then you can see the other one is comp. It's more like a zigzag, like it's coming up and down, so like that. Then you can get is skewed. So this one is skewed. Remember you spoke of skewness, and this is truncated. So it's more like going like this, truncated. And this is isolated peak. This is one peak which is isolated. Then this one is edge peaked. So you can see edge peaked. So these are common types of histogram patterns. So you should just know them. It's just good to know them about them so that you'll be able to describe them when you see them maybe in practice. So let's move on. Bar charts versus histograms. In bar charts, each column represents a group defined by a categorical variable, whilst in a histogram, each column represents a group defined by a continuous quantitative variable. So in bar graphs, it can be women. If they're women, they're women. If it's dancing, it's dancing. It cannot be continuous. But now with histogram, you can have a continuous quantitative variable, like the age of people from 10 to 12. Continuous variable. So that's the difference between the two. Histograms, they are categorical variables whilst in a histogram, each column is then a defined continuous quantitative variable. Bar graphs are categorical. Histograms are continuous quantitative variable. Let's go on to the real upper limit and the real lower limit, like I promised at the beginning of the section of the chapter. Real upper limit and real lower limit refer to the true boundaries of a class interval. They are found midway between the apparent limits of neighboring class intervals. Midpoint is equals to real lower limit plus real upper limit divided by 2. So we'll illustrate them. So for example, you are given apparent limits. Remember from the previous examples, we're just using apparent limits because I didn't want to confuse you with too much data at the same time. So let's say we're given this class interval. So you can see that 180 to 199. Then the next class is 200 to 219. So for you to determine the real class boundaries means you subtract this class interval from this. Suppose you are taking the first number in the second class and separate to the last number in the, so it's basically like 200 minus 199 and you get 1. Just to get 1. So this one now you divide it by 2. So you get 0.5. So this 0.5 now you subtract it from this one and you add it to this one. So basically you subtract on the first and add on the second number. So 180 minus 0.5 you get 179.5. 199 plus 0.5 you get 199. So if you go to the 200 minus 0.5 you get 199.5 and 219 plus 0.5 you get 219.5. So it's the same up to this. So let me refresh it. So this can work on any two pairs. So let's say you want to find the real class boundary for this one. So these two. So you have to subtract this one from this one. So 240 minus 239 you get 1 divided by 2, it's still 0.5. So you just know that you subtract on the first and you add on the last one. So that's how you get the real class boundaries. So if you apply it to the previous examples like we dealt with, you'll be able to determine the real, because here we're just using apparent class boundaries. We didn't want to flood you with a lot of information on that regard. So practice question on real upper limit, real lower limit, real upper limit. So determine the real class boundaries of the data below. It's practice question 4. So you can see these are the apparent class boundaries. So you're supposed to determine the real class boundaries. So in 5 seconds we will pause. 5, 4, 3, 2, 1, 0. Pause. Okay, I think you've determined and worked out on your own. So let's check out the solution. The solution, apparent class boundaries. So we use the same formula. You go to this one and this one. The last in the previous class, and the first in the following class. So 4.6 minus 14.5, you get 0.1. 0.1 divided by 2, you get 0.0. Forgive me of this This pen is quite difficult to draw with. 0.05. 0.05. So now what we are doing now, we are subtracting on the first and adding on the second. We are subtracting 0.05. So if you subtract 0.05 from 9.6, you get 9.55. If you add 0.05 14.5, you get 14.55. So it's the same. Subtract here and add here. Subtract here and add here. Subtract here and add here. So this is how you determine the real class boundaries. So you can determine the other one. So if you do this, well done. Class midpoint. So let's say we have a real class interval. So the real class interval from 179.5 to 199.5. So a real lower limit is 79.5 and the real upper limit is 199.5. So if you are asked to determine the class midpoint, it means just you're adding the real lower limit plus real upper limit divided by 2, then you get your midpoint. So midpoint, these ones they work when you are trying to determine the average of a class, but we will do them in the upcoming section. So it's simple enough. Let me review. So if you are asked to find a midpoint of a class, you just add the 179.5 plus 199.5. Then you divide by 2 and get the class midpoint. So it's just the average of that class. So let's move on. Practice questions for midpoints. So let's do it. So determine the class midpoints of the data given below. So this is your real class boundary. So you're just supposed to determine the class midpoints. So in 5 seconds you're pausing. 5, 4, 3, 2, 1, pause. Yeah, I guess you've managed to work these ones out, and I'm sure you got these ones correct, but they're simple enough. So let's move on to the solution. So basically we are just adding 9.55 plus 4.55 divided by 2, then you're supposed to get this class midpoint. This is simple enough. So let's move on to the next item. Thank you for watching. If you have any questions concerning this section or you need any further information, call us on 074-920-9697. Thank you.